Alright guys, welcome back, and in this area of matrices we're actually going to be looking at equal matrices today. And first and foremost, the information below is critical in us moving ahead in this topic. So it says here, two matrices are said to be equal if the corresponding elements are of the same value. So two matrices are said to be equal if the corresponding elements are of the same value. So we're going to actually start off with a very simple example for you to clearly understand what we mean. So let's take a look at the first example here. So it says, given A is this matrix here, and obviously this is a 2 by 2 matrix. So we're going to indicate that there, and matrix B is also a 2 by 2 matrix. So this is the part now that actually matters, okay? This part here. So it says if A is equal to B, determine the values of X, Y, W, Z. And if you look in the matrices here, you see those letters there. So this is the part where all the magic happens, right? Now this one example is pretty straightforward and very simple. There's not much working out involved here. So once you're told that these two matrices are equal, it means automatically that the corresponding elements must be of the same value. So let's take a look at the solution to this question. So I'm just going to put this over here. So first of all, what we need to establish is this on paper. So if A is equal to B, let's just do the solution here. It means matrix, if A is equal to B, it means that matrix A, I don't have a lot of room unfortunately, matrix A, which is X, Y, W, Z, that matrix X, Y, W, Z is equal to matrix B, which is 3, minus 1, 2, 7. So we have 3, minus 1, 2, and 7. So the two matrices are equal, right? Remember, if A equals B, determine the values of X, Y, W, and Z. So I've made A equal to B here. So it says if two matrices are equal, then the corresponding elements are of the same value. So this here corresponds with 3. So it therefore means that X is equal to 3. So I found the value of one letter. Y corresponds with negative 1. So it means that the value of Y is actually negative 1 in order for the matrices to be equal to each other. W corresponds with 2. So it means that the value of W is 2. And Z corresponds with 7. So it means that the value of Z is actually 7. So it's as straightforward as that. The only difference is that now they're not going to make it so simple in terms of saying that is equal to that or whatever, because they want to actually apply different aspects of matrices, which means some scalar multiplication is going to be involved, etc., etc. So that's what we essentially mean by equal matrices. So let's take a look at another example here. Now, example 2 is a little bit more interesting. So, here's number 2. So it says, given matrix C is negative 6, 2, and matrix D is 3A and B over 2, determine the values of A and B. Now, clearly this is a 2 by 1 matrix, and this is another 2 by 1 matrix. So again, this is where you need to focus on. In this particular case, scalar multiplication is involved because it says 2C is equal to D, unlike example 1, which just tells you this specific matrix is equal to other one. So 2C in this particular case has to be found, and then once we know what 2C is, it's going to be equal to matrix D. So the first thing we need to find out is what 2C actually is. So let's do that. So first thing we need to find out is the value of 2C. So 2C would simply be equal to 2 times whatever matrix C is. In this particular case, matrix C is minus 6 and 2. So we simply do scalar multiplication, where those elements there will be multiplied by 2. So 2 times minus 6 is minus 12, and 2 times 2 is 4, and that is what 2C is equal to. Now that we found that, since 2C is equal to D based on what they're saying, then matrix 2C, which is minus 12 and 4, must be equal to matrix D, and matrix D is that. So that would be 3A and B over 2. So again, two matrices are equal if the corresponding elements are equal. So that means minus 12. Minus 12 must be equal to 3A. So that is pretty straightforward. So minus 12 is equal to 3A. So we simply need to make A the subject and transpose for A. So we simply divide 12 by 3. That is going to be the value of A. So 3 can go into 12 4 times. It's a negative 12. So it will be negative 4. So the value of A is minus 4. Next thing. 4 here is going to be equal to B over 2. So 4 is going to be equal to B over 2. So we simply can create that equation. So 4 is equal to B over 2. And we're simply going to make B the subject. So it means 4 times 2 in this case is equal to B, which means the value of B is actually 8. So the value of B is actually 8. So this would be example 2. All right. Let's take a look now at example 3. An even more interesting question here. So it says, given matrix E is such. So matrix E is actually a 2 by 2 matrix. And given matrix G is such, that's also a 2 by 2 matrix. Now again, important part. If 4E is equal to 2G, determine the values of A, B, C, and D. So we're going to take a look at this one. Now, the first thing we need to find is 4E, and then the next thing we need to find is 2G, and then equate them, and then equate the corresponding elements, and then solve for them. So the first thing we're going to do is find 4E. So let me just put this here. First thing we need to find is 4E. So we need to work that out. So let me just slide this over a little bit. So 4E simply means we're multiplying matrix E by 4, and matrix E is this. So I'm just going to write this here. That's minus 1, that's 2A, that's 5B minus 1, which is an algebraic expression we need to put in the bracket, right? And C over 3. So what we're going to do now is just find out what 4E is. So let's deal with that first of all. So each of these elements here will be multiplied by 4, obviously. So let me just put that in. And we have 4, open bracket, 5B minus 1. Remember, the brackets are important right there. And 4 times C over 3. All right, so what we should have here is 4 times minus 1 is minus 4. 4 times 2A is 8A. 4 times B, 4 open bracket, 5B minus 1 means expansion there. So 4 times 5B is 20B. And 4 times negative 1 is minus 4. This here is a fraction, so we multiply the numerators together, so 4 times C is 4C, and we multiply the denominators together, so 1 times 3 is just 3, and this is what 4E is going to be equal to. Alright, so let me just draw this line, because we now have 4E. The next thing we need to find is 2G, which means we're multiplying matrix G by 2. So let me just get that done here. So 2G now would mean we're multiplying matrix G by 2, and matrix G is that. So it means 2 times D, 8, 11, and 10. So each of these elements here will be multiplied by 2. So obviously 2 times D is 2D, 2 times 8 is 16, 2 times 11 is 22, and 2 times 10 is 20. And that is what 2G is. Now, what we have here is what we need. So we have 4E and we have 2G, and all we now need to do is to make them equal each other and then solve for the corresponding elements. So let's do that. Let me just put this to the right here and get that answered. So, since four E is equal to 2G, that is based on what the questions stated. 4E is in fact equal to 2G. So since 4E is equal to 2G, and we know what 4E is, minus 4, 8A, 20B minus 4, and 4C over 3. So 4E is minus 4, 8A, 20B minus 4, and 4C over 3. That is what 4E is, and this is what 2G is. 2D, 16, 22, and 20. So it's 4E is equal to 2G, and 2G is 2D, 16, 22, and 20. All we need to do now is make the corresponding elements equal, generate the equations, and solve for these unknowns. So again, minus 4 corresponds with 2D. So we're just going to work those things out there. So minus 4 corresponds with 2D. So minus 4 equals to 2D. So minus 4 divided by 2 equals D. So it means that the value of D is negative 2. So we have that. Next thing, 8A corresponds with 16. So it means that 8A is equal to 16 because the matrices are equal to each other. And A will be equal to 16 over 8, which means the value of A is 2. So I found the values of 2 variables here. So next one, 20B minus 4 is equal to 22. So I can generate that equation. 20B minus 4 is equal to 22. So I can go ahead and solve for B. So 20B equals 22 plus 4. 20B is equal to 26. And B is equal to 26 divided by 20. So we can go ahead and break that down. So B would be equal to 2 can go into 26 13 times, and 2 can go into 20 10. That's an improper fraction. Final answer for B would be 10 into 13 one time, and 3 over 10. All right, so that would be 1 and 3 over 10. And the last one now, 4C over 3 is equal to 20. So 4C over 3 is equal to 20. So we can multiply both sides by 3. What we'd end up with is 4C equals 60, because 3 times 20 is 60. And of course, C equals 60 divided by 4. C would be equal to 50. So we found the answers for the 4 variables. So D is equal to minus 2, A is equal to 2, B is 1 and 3/10, and the value of C is 50. So here are 3 examples now involving equal matrices. Again, 2 matrices are said to be equal if the corresponding elements are of the same value. All right, so all you need to do is follow the information in the question, and if scalar multiplication is involved, or in more technical questions, maybe multiplication of matrices or even addition of matrices, which we'll look at in our next session. So all I want you guys to do is to remember 2 matrices are equal if the corresponding elements are of the same value. Generate equations and solve for the unknowns that are present. I hope you found this video insightful, and I'll see you guys on the next video.